that heartwarming welcome and introduction.
Very personal.
Yes, especially since it's personal. Yeah, so last time in April, I gave a presentation on application of using FRP piping in downhole or in storage cavern operations. And it was kind of feel the room sort of presentations. And I think the way that I set this presentation is kind of give an introduction so that everyone is kind of on the same page of what FRP, which is fiberglass reinforced plastics, is about. Then kind of give a cost or justification or a comparison of using carbon steel that's coated with paint compared to these non-metallic tanks. And then finally kind of the engineering aspects of what you should be aware of as far as fire or cold or any other kind of environmental exposures in order to maximize essentially the service life of your tank. So one of the things for the introduction is that, in recent years, infrastructures, and this is pretty much across the board. I think last year, I think Obama actually made a mandate saying that all infrastructures have to have some sort of plan in place in order to make sure that bridges and all infrastructures for water have to be reliable and also, have some sort of contingency plan if something goes wrong. And a lot of governments have been really vamping up and requiring either NACE Level 3 inspectors on site throughout the whole project or anything like that. And, in Mont Belvieu especially, you have SRB bacteria that have started to kind of come out in the past decade. So your corrosion rates of what it was back in the 1980s to now has been accelerated by a lot. And it's not really, corrosion of the pipe just uniformly. It's always pits and some localized areas where you'll get failures in one small area of the pipe, but a leaking pipe is a leaking pipe. So that's one of the biggest drawbacks of having steel in some of these areas. So we also want to look as far as what kind of materials have been in existence that could alleviate or kind of mitigate this kind of problem. And what I said before is fiberglass reinforced plastics. It's kind of a material that's been created in the 1950s and has been starting to be used a lot in chemical facilities, and it's starting to branch out in a lot of water treatment and a lot of construction material replacements in buildings, and also more so in especially offshore and also in exploration, downhole piping. So FRP is essentially a composite. It's taking two kinds of materials and then forming and enhancing both components into one. And it really consists of fibers, which are in it. It's kind of like rebar or concrete. And then you have your matrix, your resin matrix, which is kind of embodying the fiber itself. The most widely used ones is vinyl esters and epoxies. And epoxies, as some of you may know, is the most widely used resin and paints in existence for marine and for a lot of our plants, especially because of the fact that it's the most value and it has great adhesion properties to steel or any kind of substrate. Vinyl esters is more used for applications like coatings on concrete and coatings that require some durability in the field, whether it's abrasion resistance or other kind of aspects of the service life. Oops, what just happened there? I guess there's a button here that I'm not supposed to press. Some overall properties of the durability, that can affect the actual material itself is the specific polymer matrix. It could be a specialized kind of matrix that could be furans, or it could have certain properties that have fire resistance. It can have properties that give it abrasion resistance. It all depends on what the application or the engineering application is used for. You also have kind of a fiber volume fraction, and this is pretty important because you have to make sure that if you go to a manufacturer, you specify, what is the allowable limit, because if you let them have their way, they would put as much glass as possible and little resin as possible, because resin is expensive, glass is cheap, and most glass comes from China. And as far as the fiber cross-sectional area, you have to make sure that when you're orientating your fibers, which I'll show in a minute, it'll create stronger durability and also create a strengthening kind of aspect of the matrix itself. And also method of manufacturing, which I'll get into more later in the presentation, and also the curing environmental exposures. All of this is very important properties of FRP. So as far as the polymer matrix, as I said before, it's the resin, and it pretty much binds the fibers together and protects it from the environmental factors. One of the important things, especially whether it's brine or in chemical service, is that these fibers will protect, or will keep the vessel in its shape, but also give it some properties in order for the service life. This resin is used to protect those fibers. Once the chemical gets into the fibers themselves, you get delamination, you get peeling layers of the tank itself. So it's very important that you know what the service conditions are for the tank in order to provide the best specifications and applications of the material itself. It protects it, and also it transfers force between the individual fibers, and I'll show you in a second about the fibers themselves, how they're orientated, and provides the shape of the FRP component. This is pretty important because there might be a tight space where you might want your tank in a certain way, and the resin, it's actually pretty hard and durable. It'll give it its shape depending on what the manufacturer is calling for, or what your application is calling for as well. So the fibers themselves, they provide, it's kind of like rebar, if you wanted to compare it to concrete, and it provides the strength and stiffness of FRP. So it protects it against environmental degradation by the polymer matrix, and it is oriented in specific directions to provide strength. Oops, can't push that button again. And this is kind of what I was talking about with the fibers themselves. You can have one that's orientated at 0 degrees, and then you can orientate it, perpendicular or at 45 degrees, depending on what kind of properties you want. Normally, what we normally see is there's a mixture of both, and if you have fibers going this way and this way, it creates a strengthening effect when you're adding more layers. So depending on, and especially if it's like on the bottom of a tank, you want as many strengthening layers as possible, because that's where a lot of the weight and essentially what we have seen where most of the failures occur, more so on the bottom of the tank than on the top. There are a lot of layers, but it's also very light as compared to weight. So the strength to weight ratio of FRP is a lot more than steel itself. So you can't discount the fact that even though it's a plastic, it's not as rigid or strong as steel. It's come a long way as far as the tensile strength and a lot of the manufacturing processes of creating this material. And layup is still, it has to be some balance and symmetry whenever they produce it. All right, so that's enough introduction as far as the material, and now we get to what kind of value can this material provide for as an operator or as an owner, or in any kind of aspect in chemical exposure or brine application. So one of the things that you have to really consider, there's a lot of these factors, like the planning, design, and development cost of the actual material itself. That's you have to have engineering drawings. You have to make sure that whatever vessel it's going to replace, that it's fitted correctly. You have the right amount of nozzles. You have good vents on top of it that's designed into it, and essentially make sure that it works for your application. The purchase cost, which I'll get into more as comparatively to coated steel. The installation cost, which is comparatively the same. Some people have reported it is less, but depending on which contractors you talk to, it can be more, it can be less. So that's kind of a level playing field there. Maintenance cost is, and also the wear and loss cost, that's essentially the big value of FRP. You can install these vessels and not have to really do any work on it for 15 to 20 years if it's done correctly. And there's also liability insurance costs. If you add like fire retardant material into the resin, then the fire risk is reduced, and the thermal conductivity of FRP is like 500 times less than steel itself. So you're not going to get as much of a risk of overpressurization scenarios or fire scenarios for hazard risk analysis. Also for downtime, if it's going to be in service for 15 to 20 years and you only have to take it down, then the downtime and the lost business cost is going to, you're going to see value in that. And lastly, replacement, disposal, and recycling costs. I mean, for steel, it's heavier, it's rust, and it could be leaking because, in brine or in corrosive environments, you're going to have more susceptible to those kinds of risks. Whereas with FRP, if you design it correctly, this is not really going to be, it's not supposed to be a very big issue. There's a lot of environmental companies that have told me just recently, like they're starting to specify FRP in a lot of their applications where they do a lot of remediation, where they're doing cleanup, and then they're requiring their clients, or I guess the insurance people, the underwriters, saying that you need to install an FRP tank or an underground tank in order to utilize, diesel or this chemical, because steel only lasts so long, and as always, we try to push whatever we have as much as possible before it breaks down. So I was telling some people in here that I was going to use this, but essentially, I'm sure you guys have bought tires for your cars, and I borrowed this from Discount Tire because I'm always getting my tires rotated and just staring at it, or just it's always there. Essentially, you have good tires, you have better tires, and best tires, and they all have mileage, they all have a year's warranty, and essentially what I was trying to do as far as cost application wise, you can't really compare apples to apples of like an oil field service tank to an ASTM RTP1 tank, because I mean the amount of oil field service tanks that are out there is probably 10 to 1 compared to ASTM RTP1 tanks. But for specialized chemical service, you want to use the best in order to get the maximum longevity. However, as always, it comes at a cost,